Hello everyone, hope you're well. We're going to look at section B today, and the second part of section B, which is loaded components. Quite a few people have said they're not too confident with this, and hopefully after this you'll see that there's not a great deal to it. So B2 it is. So direct stress and strain, shear stress and strain, tensile and shear strength, and then your modulus of elasticity or the modulus of rigidity. Okay, so we'll do it by looking at previous exam questions, and hopefully you'll see how to approach these. Okay, so let's have a look at the data sheet. So this is page 5 of the data sheet, and this is where you'll go to for all these. So if you hear any of these terms, stress, strain, Young's modulus, rigidity, then you should go straight here. There are funny symbols which you don't need to remember, and they use the Greek symbols for these, but yeah, it's just knowing what these letters stand for. So that's force, that's area. Delta L, delta is used for change in, so that's change in length, and that's length. Force and area again, and then shear strain we'll get to. There's a little bit of theory that you need to understand for shear strain, but it's not really cropped up in the exams too much. Okay, so let's look at the first question. And a tricky one to start with, because there is a little bit of theory required, which is why it's worth 7 marks. This is from a recent exam. This is June 19, this one. So it's a hole punch, and cutting through a little hole, and then as you read through you'd see diameters given to you. So straight away alarm bells should ring when you see diameter or radius. Just be aware of what you've been given. You've not been given a cross-sectional area, and you've not been given a radius. You've been given a diameter, so it's likely that you're going to have to do something with that. Check the units. It's in meters, which is great. If it was in millimeters, you need to convert. It says, and the thickness of the aluminium sheet is 0.004 meters. So they've given you a thickness as well, which is a hint that there's a bit more to it for working out the area. Then it says the ultimate shear stress of the aluminium sheet is 50 megapascals. So it's, forget about anything in front of term. So it says the ultimate shear stress. You can forget about the word ultimate. It's just the shear stress. So as soon as you see that phrase, shear stress, you would go to page 5 and you'd find here, shear stress. Force over area. There we go, force over area. So that's all you've got to do. Well, if only, because this is why it's worth 7 marks. They're asking you to calculate the force. So rearranging this, it would be your stress multiplied by your area equals your force. Okay, so we have the stress, we have the shear stress, 50 megapascals. So all you've got to do is multiply it by the area. Now, this is a bit unique, this type of question. It's a hole punch. So the area is not this bit, it's not the top bit. We're not doing pi r squared here. And you might think, oh gosh, how am I going to remember this? Just you know, there's only a couple of bits of theory I'm going to throw at you in this whole presentation. So the actual area is the area. It's like, imagine you wrapped a ribbon around this edge. It's the area of the ribbon. So how would we work that out? You would get the circumference of the circle and then multiply that by the depth of it. So the circumference is 2 pi r. There's your diameter, so the radius is 0.1 meters. So 2 times pi times 0.1 gives you circumference, multiply it by the depth, which is that, and that gives you your area. And then you multiply it by the shear stress, and that will give you the force. So where are you going to get the marks? In here, 7 marks. You know, obviously knowing that mega is times 10 to the 6 is important. Being able to rearrange this equation to make force the subject, because you are asked to calculate the force. So that's the first thing you should do. Make sure that the thing you've been asked to calculate is the subject of the equation. But then, of course, there's the thing which many people in the country are going to get wrong. They're going to do the wrong area. They're going to do pi r squared using 0.1 as your radius, and going to do pi r squared, which is the wrong area. But then the hint is, of course, you're given the depth. So it's the circumference times the depth. A common wrong answer would be the cross-sectional area times the depth. No, it's the circumference times the depth. Imagine wrapping a ribbon around there. So for a hole punch question, that's what you'd have to do. Now look, that was on June 2019. So whether, it's quite unlikely a hole punch question will crop up, and a lot of them are a lot more straightforward than this, which is why it's worth 7 marks. So I'll send you this PowerPoint presentation, but here's the mark scheme there. Okay, next one. State one factor that affects stress in a cable supporting an object. So you would think stress, I know stress, page 5, direct stress, shear stress, doesn't matter. The equation is force over area. So when you just asked for one factor, well then it's force or area. There you go, force or area. Now there's a bunch more stuff you could say, but essentially you're just picking out the 2 factors from the equation that affect it. Next question. Steel cable of uniform diameter has a length of 5 meters. The cable extends by 3 millimeters when a load is applied. Calculate the direct strain. So when you see the term direct strain, that's the trigger. You go here, page 5, direct strain. Delta L over L. Delta L is the change in length and L is the length. The change in length is 3 millimeters and the length is 5 meters. So, of course, you have to convert milli into meters, so you would divide that number by 1,000, or, better still, you just do 3 times 10 to the minus 3, and then divide that by the length 5, and that will give you your answer. Now, for this, you are dividing a length by a length, essentially. You're dividing meters by meters, so meters would cancel out, so there are no units. It's a very rare circumstance, this, but it's essentially a ratio, so there's no units for direct strain. Okay, there's the mark scheme. Here's another one. So this was from, is this June 18, I think? And a steel cable has a diameter of 0.02 meters and withstands a tensile force of 3 kilonewtons. So you've seen tensile mentioned there, and then underneath you've got direct stress. So that should send you here, hopefully. So calculate the cross-sectional area of the circular cable. Nothing, special about this. Nothing's just specific to this unit here. It's just a typical cross-sectional area. You're given a diameter, which seems to be the typical thing to give you. Divide it by 2 to get the radius, and then it's pi r squared. It's essential that you know pi r squared. Okay, so once you've got the cross-sectional area, you're asked for the direct stress. Direct stress, force over area. Force, 3 times 10 to the 3, because it's kilo, divided by area, well, whatever you've just calculated for part 1. And that will give you the answer there. So the units, force over area is newtons, and area is in meters squared, so force is in newtons, so it's newtons per meter squared. Okay, pretty straightforward, I would think, as long as you remember that, you might be looking for the area and not noticing that you've just calculated it in part 1. There's your mark scheme. Right. Here's they like to put them. You get a couple of multi-choice in the middle of the exam very often, and these do crop up in the multi-choice. So identify the term that describes the ratio of tensile stress to tensile strain. So stress strain, stress strain. So that over that is this, Young's modulus. So when this is a ratio of something to something else, that means the first thing divided by the second thing. So stress divided by strain is Young's modulus. Right. Now here is this second bit of theory that you would need to know here. Now if you don't get it right, it's not a disaster. This one looks a bit tricky, I suppose, because you've got 2 sets of 50 newtons, and you're probably wondering what to do with the calculation here. So it says calculate the minimum suitable diameter for the pin. Straight away it's a bit tricky because it's asked for a diameter. You would read the question, you would spot the term shear stress, so you would go here, you'd find shear stress, force over area. So I'd write that little thing down, shear stress equals force over area. And of course you're not asked for stress, force or area, you're asked for diameter. But of course you'd want to work out the area first, and then you can work back to get the diameter there. So essentially we're after the area. So shear stress is force divided by area, so area is force divided by shear stress. The shear stress you're given 50 kilopascals. So 50 kilo is times 10 to the 3. And then the only other thing to figure out is what to use as the force. So, do we use 50? No, we don't. Do we use 100? No, we don't. And the reason is you've got to spot the difference between double shear and single shear. So here's a little bit of theory for you. If there's one thing pulling to the right and one thing pulling to the left across something, then that's a single shear. So if you've got, imagine a piece of paper which is going across your desk, and then you put the scissors to it, you're cutting across it. You're not trying to stretch it, you're cutting across it. So we call that shear. Another name for scissors is shears. You have garden shears, they do exactly that. So single shears where you've got one thing pulling one way and one thing pulling the other, or pushing. This is an example of double shear, where you've got two on one side and one on the other. That will be double shear. Okay, so if we go back here, actually I know that looks like it's single shear, but you've got something this side and something that side. So essentially you've got 50 newtons pulling that way and 50 newtons pulling up there as well. So actually, I mean, how many people in the country are going to spot that's double shear? I would guess not many. So you'd be an advantage if you do, but that is double shear. And there is a rule for double shear, so you can't just use 50 newtons. If it was single shear, you would use 50 newtons. So for double shear, believe it or not, you'd probably guess 100, you'd be wrong, you use 25 newtons. Why? Well, at this late stage, just try and remember that you do. There you go, I've written it in red. So if it's double shear, half the force. That's it, that's all you need to remember. If it's single shear, you keep it the same. So here's an example from the textbook. So you've got 20 newtons one way, haven't you, and 20 newtons the other. If that was single shear, your force would be 20 kilonewtons, 20 times 10 to the 3. But it's double shear. So that's why here the force has gone in as 10 times 10 to the 3. They've halved the force. No reason to worry about why. You won't be asked that, so you don't need to know it. Just try and remember, if it's double shear, half the force. Okay? So, here's the mark scheme for that. You can see that they've, well, actually, the mark scheme might mislead you here. They've done it a slightly different way. They've doubled the area. They've doubled the thing underneath instead of halving the thing on top, which gives you the exact same thing. So maybe the mark scheme wouldn't be the most helpful for you here, but you've just got to remember, spot that is double shear, two pulling one way and one pulling the other. So the force is 50 newtons, so you would halve it. The force you would use is 25 newtons for that question. Now once you have the area, 500 millimeters squared, then you can rearrange to get the diameter. So you're rearranging pi r squared there to get the diameter. Okay, now that's math skills, and I'm happy to go through that with you if you want. Okay, a couple more left. Now here's an example. Now this is from a sample paper, and it's well known that the sample papers are much more difficult than the actual papers that came out. So they've made it more tricky by throwing an angle in here. But let's just pretend that angle wasn't there. So you want the shear stress on the bolt. You would think, right, shear stress, force over area. Half the force when it's in double shear, that is not double shear, that is single shear. Just one force pulling one way, one force pulling the other. So it's just force over area. 15 times 10 to the 3 divided by your area. Well, 12 millimeters is your diameter. Halve it to get the radius, so 6 times 10 to the minus 3, and then pi r squared. And that's it. Of course, you've got to think about force over area. It's newtons divided by meters squared, so newtons per meter squared. That's also known as pascals, but newtons per meter squared will get you the marks. Okay, there's the mark scheme. What have we got left here? Another multi-choice. Identify the term that describes the ratio, so something divided by something else, of shear stress to shear strain. Here's shear stress, here's shear strain. Little tau and the little gamma there. So tau over gamma is this, modulus of rigidity. Okay, B. So yeah, I mean, you could end up, I suppose, going for Young's modulus by mistake. So when we're talking about the shear stress over shear strain, that's modulus of rigidity, but direct stress over direct strain is Young's modulus. So when your direct stress, direct strain is like you're stretching. Imagine a piece of blue tack, stretch it apart, or hanging a weight on the end of a wire, that type of thing. Okay, here's another example. So look, it's single shear, isn't it? So there's your force. You'd spot shear stress, so you'd go straight to the data sheet here. So shear stress, force over area. Your force is 15,000 newtons. Don't call it 30,000. It's just the single force that's pulling on one side. 15,000 newtons. And then your area, well, again, you've got the diameter. They seem to always give you the diameter. Sometimes in meters, sometimes in millimeters. So get it into meters. 20 times 10 to the minus 3. Halve it to get your radius. And then pi r squared gives you your area. Okay, 5 marks for that. Shear stress, force over area, pascals or newtons per meter squared. There's your mark scheme. So that's it. I hope that is helpful and will give you a bit more confidence with the questions relating to B2. Now, if you want more help with B2, just contact me and I can sort that out on Teams. Okay. So thanks for listening.